How many actuators do we really need in our robot arm? Actuator. A-C-T-U-A-T-O-R. Actuator. The noun actuator describes something that actuates. Which is a horrible definition, I know, so let me go a little deeper. What is something that actuates? So, broadly, outside of engineering, to actuate something means to make something move, to motivate or force something to take some motion or to take action. And in the engineering world, it's something very similar, but more specific. It's something that takes energy. It could be electrical energy, hydraulic energy, compressed air or pneumatic energy, whatever, thermal energy. It could take that energy and convert that energy into useful, controlled motion. Maybe there's some kind of signal coming in that tells the actuator how to convert that motion, like how far to move or how fast to move something. A really good example is just an electric motor. You might plug it into the wall of your house in the outlet. It takes in all that electrical energy, and depending on what you crank the dial to on the side, whatever you put that control setting on, it might make the motor spin really fast, or it'll spin really slow. Either way, it's predictable, it's controlled. You're sending some kind of control signal in there so it knows how to move. That's an example of an actuator. It converted energy into useful motion or useful kinetic energy, and it did it with some kind of control signal. The last time I worked with actuators in engineering, it was for robots. That's kind of why I had that example in the very beginning of this podcast. And the hot new trend in actuators for robots, anyway, is for making more human-friendly motors, more viscoelastic motors, softer motors, motors that aren't so hard and sharp where if you run into it or if it crashes into you, it's not going to kill you. They maybe might resemble biological motors more. For example, the fibers in your muscle, those chains of molecules, organic molecules, those are basically actuators, little tiny microscopic actuators converting food energy, for lack of a better phrase, into motion so that each little fiber pulls and pulls and pulls. And when you have a whole bunch of those little molecular actuators put together, they have this giant kinetic effect. I think actuators are cool. There's more development in the technology of actuators, and you can look it up. There are not only microscopic actuators, there are huge artificial actuators designed and used by engineers to simulate earthquakes. If you want to shake a giant heavy building, you need giant actuators. There are actuators that take thermal energy and they bend and move according to how hot or cold something becomes. Metaphorically, don't we all want to be actuators? Don't we want to take the energy around us from our environment and our community and inside ourselves and convert it into some useful action? Not just action without a purpose, but we have our control signal. We have a goal. We have an aim. We take our power, we take our aim, and we make stuff happen. Yeah, let's all be actuators. Actuators are cool, not only in engineering, but in life, and that is why it is my engineering word of the day. Hey, this is Pius. Thank you for listening once again to the Engineering Word of the Day podcast. Not only should you be an actuator, you should also listen to my long-form podcast called the K-12 Engineering Education Podcast. It's all about engineering in K-12. Go to k12engineering.net to learn more.